Hello everyone. Let's check out our next problem. So the question is, how many squares can be made from a grid of 10 by 10 dots? So kind of convenient, we're working on graph paper here, but this is some kind of, I guess this is like a combinatorial question of counting. There's nothing special about a 10 by 10 grid here. Let's just work with something smaller so we get a hold of the problem. We'll probably probably come up with a general formula here in terms of the number of the length and width of our grid. But to illustrate what this question means, let's suppose we have a grid of 4 by 4 dots. And the question is, how many squares can be made? So that's a square. That's a square. That's a square. So one way I'm thinking about doing this, any square on a grid of dots like this is going to be uniquely defined by its bottom left and top right points, right? If I tell you that this is the bottom left point and this is the top right point, then we have our square. Maybe that's not the best way to do it though, because not any selection of 2 points can properly correspond to a bottom left and top right. Let's maybe parameterize things by saying which point is the bottom left point in any particular square and the size of the square. And by size I mean side length. So if I give you which point is the bottom left, and if I give you the side length, in this case it can be 1, 2, or 3, that uniquely defines the square. Okay, so parameters. So the bottom left point itself is in fact 2 parameters, x and y, and side length, which we'll call S. So really what we need, any point out of these 9 can act as the bottom left, and then what we need to do is count how many possible side lengths can be chosen. So if that's the bottom left point, there are 3 possible side lengths we can have, 1, 2, or 3. If this is the bottom left point, there are only 2 side lengths that can be chosen, 1 or 2. If this is the bottom left point, there's only 1 side length that can be chosen, and it's 1. And it looks like so given, in fact, let's call this point here 0, 0. And so this point here is 3, 3. So if we're given xy with x less than or equal to 2 and y less than or equal to 2, what is the number of allowable side lengths? This will depend on the maximum of x and y, right? If x is larger than y, so a point like this, the restriction on how many side lengths we can have is x, is the x coordinate, not the y coordinate. So for example, if that's the bottom left point, there's only one side length we can use, and it's 1. If this is the bottom left point, there are only 2 side lengths we can use, 1 or 2, and that depends, that's because the x coordinate is larger. And so what I'm seeing here is that if I draw lines like this, connecting these dots, the number of side lengths that I'm allowed to choose here depends on which of those lines I'm on. If I'm on this line, there are 3 side lengths I can choose. If I'm on this line, if I'm anywhere on this line, there are 2 side lengths I can choose. Yeah. Oh wait, no, this is not correct. This is not correct. This is not correct at all. There's only one side length, there are 3 different side lengths I can choose for those points. Either of these 2 points has 2 side lengths that I can choose. But on this straight line, it's different. This point only has 1 possible side length. This one has 2 possible side lengths, and that also has 1 possible side length. Interesting. And these 2 points both have 1, and that point has 1. What is the... I mean, we could just count it in a diagram like this, but if we want to extend this to a general number of dots, or up to 10 possible dots, I don't really want to count. It would be nice if we had a formula that we could just sum over or something like that. Let me write out for each dot, I'm going to write out the number of side lengths we can choose corresponding to each dot. So we have 3, 2 and 2, 1, 2, 1, 1, 1, and 1. Ah, funny, yeah. You'll notice these are all 1, these are all 2, and that's a 3. Okay, so this was that was kind of cool to see. And that's got to be a general pattern, right? Like if I let me draw the dots more spread out, and I'll draw it for a larger grid. So I've drawn a 6x6 grid of dots here, and the pattern here should be, I mean, it should be clear. If the bottom left corner of the square is any of these dots here, then the size of the square must be 1. So there's only 1 possible side length that we can use. If any of these dots are the bottom left dot in the square, then the side length of the square must be 1 or 2, and so on as we sort of move farther down. If any of these dots are the bottom left dot in the square, then the total number of side lengths, or the side length must be 1, 2, or 3. So what I want here is I have a summation. So the number of side lengths I can choose for the bottom left. Let's say we have n by n grid. The total number of squares is going to be n minus 1. That corresponds to only this point here, right? There are, in my 6 by 6 grid, there are 5 squares that have this as the bottom left corner. And then I have plus 3 times n minus 2, because there are 3 dots. 3 dots corresponding to n minus 2 possible choices, plus 5 times n minus 3. And this is going to go up to what is this going to go up to? How many dots are there here as a function of n? It's going to be, it's 2n minus 1, right? 2n minus 1 times 1, right? In a 6 by 6 grid, well, how many do I have here? I have 5 plus 4, which is 9. Yeah, this is wrong. This should be 2n minus 3 then, I suppose, isn't it? Now I wonder if there's a nice formula for this. What do I actually have? Maybe I can write this as a proper summation. So I have a sum. How many terms do I have in the sum? 1, 2, 3, 4, 5, which is really n minus 1. I'll have this go from 1 to n, where I have n minus, that'll give me n terms. N minus k, right? And what am I multiplying by here? So these are the n minus k's, right? That's an n minus k, that's an n minus k, and so on. As my index k increases by 1, these terms in parentheses are always decreasing by 1. So this makes sense. And what is this term out in front? It's something which is increasing with respect to k. It's increasing by 2. So is it just 2k? Nope, because I only want the odd numbers. So it'll be 2k, is it 2k minus 1? Yeah, it is. When k is equal to n minus 1, I get 2n minus 3. Okay, so does this have a closed form expression? Well, let's break it up into 2 different sums. Does it make sense to break it up into 4 different sums? I don't know. I'm just going to sort of expand things here until I get to a point where I think I can make sense of things. So n factors out of this, and I simply have here a sum of odd numbers. When you add up consecutive odd numbers, you always get a perfect square. So we should have a closed form expression for that. It'll be a perfect square depending on n, but we'll come back to that in a moment. And I have here k going from 1 to n minus 1 of k squared with a factor of 2 in front. Sum of squares, is there a formula for that? I don't know. Maybe, probably. Could look that up. And then I have plus sum as k goes from 1 to n minus 1 of just k. And that certainly has a closed form expression. Okay, so sum of consecutive odds. So we're starting with k equals, when k is equal to 1, this number is 1. So we have 1 plus 3 plus 5 plus 7, all the way up to the number 2n minus 3. And what is that going to be? So if n is equal to 6, equal to 6, we have 5 terms. So it's kind of just counting up how many dots there are in that big square there. So it should just be n minus 1 squared, right? It's going to be, if n is equal to 3, then I have 2 terms in this sum, and they add up to 4. So that's 2 squared, yeah. Okay, that's good. What is the formula for the sum of squares? I mean, I know it's something that's cubic, which depends on the total number of terms. Is there an easy way of figuring that out? I know there's a formula for this for sure. There's a formula for that. Let me just keep it as minus 2 of whatever that sum is. And here we have, the sum of consecutive integers. We'll take the first term plus the last term divided by 2, multiplied by the number of terms, which is n minus 1. And that should give us what we want. So we have n times n minus 1 squared minus 2 times this sum, and n times n minus 1 over 2. Okay, so I know there's ways of figuring out with geometric arguments and so on what this summation is in terms of the index n, but the main part of this problem really was recognizing this pattern that this collection of dots has, each dot highlighted here has the same number of possible squares where the dot corresponds to its bottom left point in the square. and then it just becomes a counting or summation argument. Yeah, so we stumbled through a little bit before actually finding this pattern, but then once you write it down, it actually becomes kind of obvious. Cool problem.